In this video, we'll do some examples of logarithmic equations. So one of the things we often have to do in calculus is solve logarithmic equations. And basically, we use the idea of either converting back to exponential form. Remember, if you have log base A x equals y, we can convert that to a to the y equals x, or use the property that log base A of A equaling the log base A of B implies that A is equal to B. So let's take a look at some of these equations. One thing we should note is that we always have to check our solutions because the domain of a logarithm, log base A of x, our x value has to be greater than 0. We know that we cannot take the logarithm of 0 or a negative. So we didn't have to do that with our exponential equations because the domain of an exponential equation is all real numbers. So let's take a look at some of these. In the first example, we're using this first method. Because I just have a logarithm and I have a number on the other side, as long as I can isolate the log, I can just convert it. So I'm going to divide both sides by 4. That will give me the natural log of x equals 9. Converting that to exponential form, I'll get e to the 9 equals x. Now I'm pretty confident in that answer, but I do need to check my work. So if I say 4 times the natural log of e to the 9th equals 36, you'll notice that bringing this down, 36 times the natural log of e equals 36. And since the natural log of e is 1, this in fact checks. What we're checking for mostly is that I'm not trying to take the log of a negative number. If I'm asked to take a negative log of a negative or 0, then that's when we're going to toss that answer out. So looking at our next example, it's very similar. It's already a log equal to a number, and it's isolated, so we're going to convert it. 3 to the first equals x cubed minus 5. 3 to the first, of course, is just 3, so adding 5 to each side gives us 8 equals x cubed, and then taking the cube root of both sides, we get 2 is equal to x. Unlike a square root, we don't take the positive and the negative because, of course, negative 2 cubed gives us negative 8. I do need to check my solution, and really, again, what I'm checking is that x cubed minus 5, which is the argument here, is a positive value. So that would give me 8 minus 5, or 3. So this, in fact, does check. For this next example, we don't have a single logarithm. We actually have 2 logs on the left and 1 log on the right. If I could write it as a log equal to a log, I could use that second property. So the first thing we're going to do, and we've practiced this, is condense these two. So because it is a plus sign, these 2 arguments should be multiplied. So we get the log of 2x squared plus x equals the log of x plus 8. So at this point, we use this property. The log of a equaling the log of b tells us that a is equal to b. I want to be extremely clear here. We are not dividing out the logs. We are making a logical step that if the log of this number equals the log of this number, then those numbers must be equal. So I should not see anybody canceling out those logs. the next step would just be to say 2x squared plus x equals x plus 8. If I subtract x from each side, I get 2x squared equals 8. And at this point, I have a couple of options. I can either subtract the 8 and set it equal to 0 and then factor, or I could divide by 2 and take roots. That's the way I'm going to approach this. So I'm going to divide by 2, leaving x squared equals 4. In this case, when I take the square root of each side, and we're putting it in, so we're going to take positive and negative, we get x equals 2 and x equals negative 2. I do need to check these answers. And again, what we're checking for is that these arguments here, 2x plus 1, x, and x plus 8, will be positive. So when I do x equals 2, I'll get 2 times 2 plus 1, that's 5, that works. I'll just get 2 for the second log, and I'll get 10 for the third. So x equals 2 is a good solution. X equals minus 2, on the other hand, when I plug this in, 2 times negative 2 plus 1 gives us negative 3. And I can't take the log of a negative value, so that's why I'm going to get rid of that answer. So again, I want to be clear that I didn't get rid of that answer because that answer was negative. I got rid of that answer because I was asked to take the log of a negative when I plugged it back in. Okay, so just to recap, the domain of a logarithm is x has to be greater than 0. So it's always necessary to check that your proposed solutions result in logarithms of positive values, positive numbers, in the original equation. So checking it is part of the process. Here's another example. When we want to solve log base 3 of 4x plus 1 times x plus 1 equaling 3, which of the two properties should I use? Well, I don't have logs on both sides. I only have a log on one side of the equation. So in this case, I can convert it to exponential form. So this would give me 3 to the third equals, and I'm going to go ahead and multiply this out, 4x squared plus 5x plus 1. So 27 equals 4x squared plus 5x plus 1, or 4x squared plus 5x minus 26 equals 0. So we have a quadratic here. We could try to factor this. I'm wondering 26 times 4 gives me 104. I don't believe that this factors, so I'm going to go ahead and use the quadratic formula. I will get x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. That's going to give me negative 5 plus or minus the square root of something over 8. 441. I guess this did factor because this is negative 5 plus or minus 21 all over 8, which gives us two answers of x equals 2 and negative 3.25. We're not done. These are potential answers. We still need to check these. So when I check them, I need to make sure that this product is positive. So let's go ahead and check. If x is 2 and I plug that in, I get 8 plus 1, which is 9, and 2 plus 1, which is 3. So that should work. If I check negative 3.25, I get 27 as well, and that checks. So here's a situation where both of our answers, even though one of them is negative, does work in the original equation. So that this video doesn't get too long, I'll do part 2 of logarithmic equations, where we'll do a few more examples and also some applications.